Alright, this is lesson 3.7. I can graph data to demonstrate relationships. Remember graphing ordered pairs? You're going to need to remember how to do that in order to graph data. So just as a quick review, we have our x-coordinate and our y-coordinate. This x-coordinate is the one you graph on the x-axis, which is to the left or to the right, and the y is up or down. Alright, so first what we're going to do is we're going to remember back to those function tables where we had that domain and the range, and we're going to just choose some numbers. It doesn't matter what numbers you choose. Let's go with 0, 1, 2, and 3. Nice, easy, small numbers. I also want my numbers to be able to fit on my graph. So I'm going to plug in the 0, the 1, the 2, and the 3 in for my x, because that's the variable I'm filling. So I'm going to say 0 plus 1. 1 plus 1, 2 plus 1, and 3 plus 1. See how I just replace that each time with the number that was in this column. Alright, so then I have my answer over here, 1, 2, 3, and 4. This creates an ordered pair. Here I have a 0, 1. That's the ordered pair 0, 1. Then I have 1, 2, 1, 2, 2, 3, 2, 3, and 3, 4. How do I graph this line? Well, all I need to do is put these points on the line, or put these points on the graph and make a line out of them. So over 0, up 1. Let's see if I can do this. It's a little tricky with the iPad here. 1, 2, 1, up to 2, 2, 3, and 3, 4. Alright, so you can see they're all falling in a line. If you have one that's a little out of place, you know that you did something wrong and you need to go back and check that one, because these are all linear equations, which means they should all form a straight line. Let's do another one. Okay, so here we have the function 2x minus 1. Again, I'm just going to plug some numbers in. I think it's always nice to have a negative number, because every now and again when you get to a function that's not linear, it's going to do something different on the other side of the 0. So it's smart to always have a negative, even though it makes it a little tougher. Alright, so I'm going to make this one more challenging and have the negative sign. So this one I'm going to say 2 times negative 1 minus 1. 2 times 0 minus 1, 2 times 1 minus 1, and 2 times 2 minus 1. So I'm going to do each problem. So I get negative 2 minus 1. It's going to be negative 3. 0 minus 1 is negative 1. 2 minus 1 is 1. And 4 minus 1 is 3. Alright, so you can see how I can put the x and the y together, and I get negative 1, negative 3, 0, negative 1, 1, 1, and 2, 3. So I'm going to put those on my graph. Negative 1, negative 3 is down here. 0, negative 1, 1, 1, and 2, 3. Okay, you can see those line up in a straight line. And make sure that your line has arrows on either end, because that means it's going to keep going in either direction. Okay, so we're going to skip a little bit and say, now what if we just had a box with x's and y's? Could we do this? Yeah, you're going to have to do these problems either in your head or somewhere off to the side. We're going to try doing them in our head. Let's stick with 0, 1, and 2 so that we don't do any tricky negative business in our head. So first we're just going to plug it in our head. 3 times 0 is 0, plus 2 is 2. Okay, 3 times 1 is 3, plus 2 is 5. 3 times 2 is 6, plus 2 is 8. I'm going to graph that. 0, 2, 1, 5, and 2, 8. Okay? Next, I have y equals 3x minus 2. So notice that these two equations are very similar, only this one's a plus 2 and this one's a minus 2, and we're going to notice how that changes our equation. So first, let's just graph the same points, 0, 1, and 2. 3 times 2 is 0, minus 2 is negative 2, 3 times 1 is 3, minus 2 is 1, and 3 times 2 is 6, minus 2 is 4. All right, we'll graph that. 0, -2, 1, 1, and 2, 4. Do you see how these lines end up being parallel to each other? One's just a little bit lower than the other. This part that I've circled here, that's showing you where the line is going to run into the y-axis. We call that the y-intercept. It's not something you have to know yet, but it's definitely helpful when you're trying to pick out lines. So this is saying this is going to run into the line at 2, and it did. This one's going to run into the line at -2, and it did. This 3x is saying that every time you go over 1, you're going to go up 3. Do you see how I went over 1, up 3, over 1, up 3? Same here, over 1, up 3, over 1, up 3. We call that the slope of the line. Let's do this again. Now maybe you can make some predictions. This one should run into the y-axis at 1, and this one should run into the y-axis at -1. Again, they're going to have the same slope, so they should be just as steep of lines as these first ones. Okay, so let's do 0, 1, and 2 again. When I plug in 0, I get 1. When I plug in 1, I get 4. When I plug in 2, I get 7. So we'll graph it 0, 1, 1, 4, and 2, 7. Okay? And again, we've got another parallel line running in to the y-axis at 1. Exactly what we predicted. Let's do this one in green. So we've got 0, 1, and 2. I'm going to plug these in. So I've got -1 as my answer. I've got 3 minus 1 is 2, and 6 minus 1 is 5. So I'm going to graph this 0, -1, 1, 2, and 2, 5. Got them all in here, all parallel to each other, and that's my graph of those. I want you to try this. Pause the video and try graphing this one using these values that they gave you. So they gave you some negative values too. Okay, so once you plug these in, you should have gotten -9 plus 5 is -4, -6 plus 5 is -1, 0 plus 5 is 5, and 3 plus 5 is 8. So we'll graph that. -3, -4. Okay, -2, -1, 0, 5, 1, 8. Okay, and that's my line. All right, sometimes you're going to have some multiple choice questions where it wants to know what's the graph of this function or this equation here. And there's a couple ways we can do this. One is we can just graph this on any one of these lines. It doesn't matter which one. And after we graph it, we can see which one matches. Or we can look at those things that I taught you, that this is going to be where it runs into the y-axis, and this is going to be its slope. So let's first look at that just to see if we can eliminate anything. And so this is saying I'm running into my y-axis at 3. Let's see, 1, 2, 3. This one runs into the y-axis at 3. It matches it. 1, 2, 3. This one, oops, 3. This one does not. So this one should not be the correct answer. We'll find out for sure, though, in a minute. This one, 1, 2, 3. 1, 2, 2, 3. This one also should not be it because it does not run in at the correct place. So we should have the option of A and only A based on this information only. But let's go ahead and do our X and Y's. Just a couple of them to check in and see if this one matches my other point. So let's just do 0, 1, and 2. When I plug in 0, I get 3. When I plug in 1, let's see, I get -2 plus 3 is 1. And when I plug in 2, -4 plus 3 is -1. All right, so let me graph this, and I'm going to go ahead and graph it right on letter A, since that's the one we're thinking it's going to be. So we got 0 and 3, we've got 1 and 1, and we've got 2 and -1. Sure enough, all of those points land right on my line, and I know that that is the correct one. Take a second and try this one. Unfortunately, this one doesn't have a plus or a minus anything, but we can assume that means it's +0 or -0. So that's showing us it runs into the y-intercept at the origin. It's 0, 0. We can also see that the slope is -4, so every time I go over 1, I go down 4. But I bet you graphed this, x and y's, 0, 1, and 2, and you graphed and found out that it does indeed match letter B. Okay, the last one. I want you to pause the video and try this. Okay, so what I did was I looked at this in two ways. One, I said, okay, I could look at my little secret hint that I said and say this is where it runs into the y-axis. That doesn't help me much here because do you notice it's not running into the y-axis? But if I were to imagine this line continuing, I can imagine that this is going to be a negative number, right? So I can probably say it's probably not going to be this one or this one because that I should be able to see those. They should be up here running into the line. So it's going to run into the line somewhere below, either -1 or -5. Maybe you've already made your prediction as to which one where it's going to run into that. But what's really smart to do is to pick a point that you see on this graph that's easy to read. For example, this one. Okay, so this point is the point 3, 4. I'm going to test this and see which equations does this work for. So this is my x and this is my y. When I plug in 3 for my x, does my y come out 4? 3 minus 1 is not 4. That equals 2. So it's definitely not A. It didn't work for that. 3 plus 3 is also not 4. 3 times 3 is 9, plus 1 is 10. That's not 4. 3 times 3 is 9, minus 5 is 4. So there you go. It's letter D. You could graph all 4 of these equations on the line, and one of them is going to line up right on top of the other one, and the only one that's going to do that is letter D. I think these little secret hints helps you to make it go faster. All right, don't forget to do your NICU check. Come with questions tomorrow.